Hi, this is David Voss, CCIE 11372, and in this video you're going to receive an introduction to wireless LANs. Specifically, we're going to do an overview of wireless LANs, talk about wireless LAN components. We'll talk about the 802.11 standard in the OSI model, how it fits in the OSI model. Then MAC sublayer coordination, how that applies to wireless, 802.11 frame types, and finally, wireless LAN standards. So wireless LANs provide network connectivity almost anywhere. Surely you use wireless LANs. If you're in technology, surely you're using them, whether it's your mobile phone or your laptop, whether you're at a coffee shop or at your place of business doing BYOD. Wireless LANs typically can be implemented at much less cost than traditional wired LANs. The wired infrastructure is, of course, based on the 802.3 standards, but a wireless network uses radio waves to transmit data and to connect devices. So as you surely know, a wireless network uses radio waves to transmit data and connect devices. Wireless LANs are defined by the 802.11 standards. Now, some additional advantages of wireless LANs over wired LANs include the following: monetary cost, flexibility, that you allow users to roam in places where they normally cannot, or use their devices in places they always wish they could. Load distribution, and finally redundancy. And we'll get into this in a little bit, but using these wireless access points, multiple wireless access points in one area, can provide redundancy and load distribution at a much more affordable cost than wired LANs. Now, there are certain components that make up wireless LANs, and let's start with the client, specifically you or any of our customers. Clients are basically an appliance that interfaces with the wireless medium. Now, again, that could be a mobile device, it could be a laptop, it could be a tablet, it could be a PC, but it's basically a device that operates as an end user device. An access point functions as a bridge, basically, between the endpoints and the existing network backbone. So the access point is what the endpoints are actually communicating with, and as they roam, they may change access points throughout the building, but the access points are actually what are getting them access to the network. As you can see in this picture, access points come in many different shapes and sizes. These are just a few examples of access points. The distribution system plays a key role in communications between the customer who's trying to get on the wireless network and the major wireless LAN components that are actually routing the traffic. The distribution system allows for the interconnection of the APs of multiple cells. Think of your organization. If you have one area that's considered a lab and it's a wireless lab, and that ultimately needs to communicate with marketing on the 8th floor, you're going to need a distribution system to communicate between those two locations. The wireless distribution system allows you to connect multiple access points. So with wireless distribution systems, APs can communicate with one another without wires in a standardized way. Now, that being said, distribution could be wired or integrated. But this capability of communications between access points is absolutely critical in providing a seamless experience for roaming clients and for managing multiple wireless networks. It can also simplify the network infrastructure by reducing the amount of cabling required. Another concept you need to understand is the basic service set. The wireless architecture divides the system into cells, referred to as basic service set, and it's controlled by a base station, or more commonly, an access point. Now, an extended service set is a set of connected BSSs. And then there's the independent basic service set, which is a wireless network consisting of at least 2 endpoints and no distribution system. So let's draw this out so we can get a better understanding of what we learned thus far. So in any wireless implementation, you're going to have endpoints that need to connect. So for example, here's a laptop that is connecting to the wireless network. It connects to the wireless network through an access point. The access point is sending out the radio waves, which are being received by the laptop. The laptop endpoint then connects onto the wireless network, assuming it has the proper security configurations, and it can then reach the network. Now, access points can communicate not only with laptops, but again, mobile phones. And you can think of this as a basic service set. Now, let's say in a different area, we have another access point, which is also serving customers or users. And this, again, could be a server, it could be a workstation, could be a printer. But regardless, it's servicing endpoints. It's a different implementation, different part of the building or a different building altogether, but this is another basic service set. So how do these two basic service sets communicate? Well, they use, as you have already learned, they use a distribution system. These two DSs can uplink in many ways via wireless, or in this case that we're looking, here's a wired connection. This is the distribution system that is allowing these two separate wireless implementations or basic service sets to communicate. Now, if we look at the big picture, both of these basic service sets and the distribution system, the big picture, this is the extended service set. This includes all of the wireless equipment and any equipment used to connect the wireless equipment together. The IEEE 802 standards define two separate layers for the data link of the OSI model. As you know, these two layers are the LLC and the MAC sublayers. The 802.11 standards cover the operation of the MAC sublayer and the physical layer. The 802.11 frame consists of a 32-byte MAC header, variable length, and a frame check sequence. There are two types of coordinated functions used to ensure collision-free access on a wireless network. First, distributed coordination function. The MAC sublayer technique employs the well-known CSMA-CA to avoid collisions. It's used to manage access to the radio frequency medium, and it's composed of the following two main components: interframe spaces and random backoff. And then there's point coordination function, and the PCF is used by the AP to coordinate communications with the wireless network. The 802.11 standard uses three main types of frames: control frames to control access to the medium, management frames to enable stations to establish and maintain communications, and then data frames sent by any endpoint, and these contain higher layer protocol information or data. Now, there are many 802.11 standards, but you should definitely know of these, and you probably already do know many of them. These standards have been rolled out over the years, and you've been on many of these networks, whether it's in your home or at your local coffee shop or at work. The initial 802.11 standard was serviced up to 2 megabits per second. At this point, we're at the 802.11n standard, which theoretically can provide up to 600 megabits per second of bandwidth. So here's what you've learned. We've done a wireless LAN overview. We've talked about wireless LAN components and how the 802.11 standard works with the OSI model. We've talked about MAC sublayer coordination and how that applies to wireless, 802.11 frame types, and finally, wireless LAN standards. Good luck with your studies.